This video is the second in the question of how do you know whether you're doing washers or shells. In the last video, we rotated this region around the line y equals -1. We did it both calculating with washers and with shells. This time, I'm going to rotate around the line x equals 4. So a vertical line, x equals 4. This is going to rotate out at you, coming back down in over here, and like that. So there's this big, it's kind of rounded on the outside and conical on the inside, and there's a big hole in the middle here. Okay. I want to calculate the volume. Okay. I have a vertical axis. I have a vertical axis of rotation. Right? I need to divide my region into a bunch of little rectangles. Am I going to take vertical rectangles? Am I going to do horizontal rectangles? Well, I'm going to do both. But let's start with vertical rectangles. Right? For every value of x between 0 and, in the last video we calculated that this was 4. For every value of x, I've got one of these little rectangles. Right? Each rectangle is rotated around to generate, what does it generate? Wow, everything just disappeared on me. Can I do an undo? Undo. We've got shells. Sorry, I'm a little frazzled here. My computer's doing weird things, but we're back. So we've got these cylindrical shells, and we're trying to calculate the volume. So what do I need to know? I need to know, first of all, is this a dy or a dx? And I notice that this thickness here is a very little bit of thickness in the x direction. So this is a dx. It's shells, so I need 2 pi times a radius. 2 pi times a radius. Now the radius is the radius of that shell. And for each value of x here, for each value of x, I've got a shell. X is going to be really small, close to 0. X is going to be all these values in the middle. X is going to be all the way up to 4. Every single one of those is going to have one of these shells, which is why we're doing an integral dx, right? Because we're going to add them all up. So what's the radius of that shell? The radius of that shell is this length right here. That length right there is a horizontal length, and so I need the x value on the right side minus the x value on the left side. Well, the x value on the right side is 4. The x value on the left side is x. That's one's going to change depending on which x you choose, right? But the 4 is always staying the same over here on this side. So 2 pi times the radius times the height. What's the height of that shell? Well, that's a vertical measurement, so I need the y value on the top and the y value on the bottom. Well, the y value on the top is the square root of x. The y value on the bottom is a half x. 2 pi times the radius times the height times dx. What values of x am I interested in? Well, the smallest value of x is 0. The biggest value of x here is 4. So that should calculate the volume generated by this thing as it rotates around, this region as it rotates around the line x equals 4. Okay. Now I want to do the same region, rotate around the same axis, but I'm going to turn my rectangles sideways. So here we go. Let me grab a blue pen to start with. Let's move on up here. So I'm going to draw the picture again. I've got y equals a half x out to 4 there. I've got y equals the square root of x. I rotate around the line, x equals 4. I'm trying to do an arrow going around that line, and I'm not always successful at doing that. Now, I'm going to, instead of doing vertical rectangles this time, I'm going to do horizontal rectangles. I'm going to, for each value of y between 0 and 2, I've got a horizontal rectangle. It will get rotated around to generate a washer. the axis that I'm rotating around is vertical. The rectangle that I'm rotating is horizontal. They're perpendicular to each other, generating a washer, just like when we had the picture turned sideways. So let's see, doing washers. I need an integral. Is this an integral dx or dy? Look at that. In this direction, this is up and down, tiny little bit of thickness there. That's in the y direction. This is a dy. So the volume is, what values of y am I interested in? Well, y goes from 0 out to 2. And for each value of y, you've got one of these rectangles, right? You got some for these y's down here, these y's there, these y's here, even over there. You got them. For every value of y, you've got one of these rectangles. How do I do this now? I need pi times an outside radius squared minus an inside radius squared. Well, the outside radius is, let me get another color here. Let me get another color. There we go. The outside radius is the distance from the axis all the way out to the outside. Notice that's a horizontal measurement. So I need an x value right here, 4, minus the x value right there. Well, that x value depends on which y you've chosen. So let me calculate this here. X is y squared. So 4 minus y squared is that radius. X value minus x value. Inside radius. Grab another color. How about something I haven't used? Purple. This radius right here from the axis over to the inside part there. That's again a horizontal measurement. So I need the x value on the right, which is 4, minus the x value right there. Well, that's y equals a half x. So solve for x. X equals 2y. Right? It depends on, when y is down here, x is pretty small, but when y is up here, x is pretty big. It all depends on which y value you have. Sorry, it's doing really weird things with my pen. So 2 minus y is the x value right there. And this should give you the same answer that the previous integral did. Okay? You can do washers, you can do shells. You can't just arbitrarily do them. You've got to know which you're doing. If you're rotating around a vertical axis and you're splitting it up with vertical rectangles, you're doing shells. If you've got a vertical axis and you're splitting it up with horizontal rectangles, you're doing washers. It really, 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 really is a good idea to draw a picture so that you know which it is you're doing. The picture will also tell you whether you're doing an integral dx or dy, because the thickness, that tiny little bit of thickness on your rectangles, is either in the up and down direction, that's a dy, or it's in the sideways direction, that's a dx. Okay. There's one more thing I was going to say, and it is escaping me, so I'm going to pause. It may seem like you always have your choice as to which one you want to do. In some ways, yes, and in some ways, no. If you tried to do, for instance, we did the example of taking one bump of the sine curve, y equals sine x, and rotating that around the y-axis, right? We did it with vertical rectangles generating shells. If you tried to do it with horizontal rectangles, it's not impossible, but it is tricky. Because you got y equals sine x, and you're rotating around this way. So if you're trying to do it like this to generate washers, that should go all the way out there, then I'm going to need to know an outside radius and an inside radius. Well, each of those is determined by this curve y equals sine x. I need the x value here. I'm going to need the x value there. Well, so if you try solving for x, you got x equals what? Arc sine y, inverse sine y? Well, it turns out that inverse sine y is this x value. How do you get that one? Now, it's not impossible. I mean, just if you know some things, this is pi out here. So if this is arc sine, then that's also arc sine. So this x value is going to be pi minus sine inverse y, and this x value there is just going to be sine inverse y. So Yeah, you can do it. You can find that outside radius. That's the outside radius right there, that x value. And the inside radius here. You're going to square this one, you're going to square that one, you're going to subtract, and then multiply by pi, and then integrate the whole thing from 0 up to 1. It's just that it's not very convenient to use horizontal rectangles here. It's actually very convenient to use vertical rectangles. Your top is always on y equals sine x, your bottom is always on y equals 0, and you can just do it. So yes, you do have options, but sometimes one option is really substantially more difficult than the other. So you want to learn both methods, shells and washers.